Okay, in this video, we are going to take a look at a little bit of everything that we did in Unit 3 to get ready for our tests. The first thing I wanted us to look at is transformations. So it's more like, hey, what are the transformations from one function to another function? So for example, if my first function of f of x equals to 3 times the quantity of x plus 5 squared minus 1, and I wanted to go from f of x, that function as I just mentioned, to g of x, what are the transformations that happen? So what I'm going to do is I'm going to take a look at each part of the equation and compare it from the first to the second. And if I'm looking at this, first I went from this 3 on the outside, so that's a vertical stretch just by looking from the parent function on the f of x. But to go from the 3 to a 9, I actually have to multiply that by 3. And when I do that, that itself is a transformation. Okay, so because I'm multiplying, it's either a vertical or horizontal stretch or shrink. And since this is outside, both of these numbers are outside of the parentheses, I know that multiplied by 3 is going to be a vertical blank by, in this case, I'm multiplying by 3 to get to the new equation, the new number. So that would be multiplied by 3. So because I am multiplying by 3 bigger than 1, I know that this is a vertical stretch by 3. So that's the first transformation to go from f to g. The second one that I'm looking at, I look at this inside. I have a plus 5 on the inside. And that plus 5 becomes a plus 7 on the inside. Well, how do I do that? I added 2 more. Okay, so whenever I'm adding on the inside, adding and subtracting on the inside, that tells me that I'm moving left or right. And because I'm not following the rule on the inside, plus 2 becomes translated left 2 units. So translated left 2 is another transformation. So I got from 3 to 9 and multiplied by 3. From 5 to 7, because this is already talking about adding and subtracting, I have to add from 5, add 2 to get 7. That's going to get me my translated left unit, 2 units. And last but not least, a number on the outside. I got a minus 1. To go from a minus 1 to a plus 3, I have to add 4 units. And because this is outside, I know I'm moving either up or down. Since it follows the rule, plus 4 tells me that I am translating it. It has translated up 4 units. So if I have to list the transformation from f of x to g of x, I know that I'm going to be looking at a vertical stretch by 3, translated left 2, and a translated up 4. So that's an example of transformation. Now, keep looking. This, for the next 3 problem is going to be from our review sheet. So I'm going to look at problem number 2 on the review sheet, problem number 3 on the review sheet, and problem number 6 on the review sheet. And all 3 of these ask you to identify the vertex and the axis of symmetry. The reason why I chose these 3 is because the first one, number 2, is a standard form. And the second one is in vertex form, and the third one is in the x-intercept form. So there's different ways to find axis of symmetry and vertex in each of those forms. If you look at your formula chart, you would find that there is an axis of symmetry formula on your formula chart. That is x equals to negative b over 2a. Remember that you can use your formula chart on your test, so you don't have to memorize that, just know where to look for it. Alright, and that axis of symmetry formula can only work for a standard form. So it won't work for vertex form, and it won't work for x-intercept form. So let's take a look. if you're looking at number 2, this is the equation that they give you. Y equals to x squared plus 20x plus 103. That is a standard form because you have your A which is your 1. You have your B, which is your positive 20. And then you have your C, which is your positive 103. Okay, to find the axis of symmetry, my AOS, because this is in standard form, I know I can use this formula, negative B over 2A, which I already have labeled. So axis of symmetry, x equals to negative B over 2A. So plugging it in, x equals to negative, and then B, my B is 20, so I'm going to write 20 over 2 times my A is 1, so 2 times 1. So that's going to give me negative 20 over 2, leaving me with axis of symmetry of x equals to negative 10. Alright, so that's my axis of symmetry. Knowing the axis of symmetry also can get me to my vertex pretty smoothly. So to find the vertex, you know that axis of symmetry is in the middle of the graph. It splits the graph in half. And the vertex is the middle point of the entire graph. So that means that whatever you get for axis of symmetry, that's going to be your x value for your vertex. So negative 10, comma, something. Now that I have a x value, I have an equation. I can take the x, plug it into the x's in my equation, and work it out to solve for y. So with that, that's going to give me x squared. That's going to be negative 10 squared plus 20 times x, so 20 times negative 10 plus 103. And that's going to give me my y. Okay, working it out, negative 10 squared. Negative 10 times negative 10, that's going to give me 100. 20 times negative 10 is going to give me negative 200, so minus 200 plus 103 equals y. Working it out, 100 minus 200 is negative 100 plus 103 equals y. This gives me 3 equals y. So that 3 right there goes in to this spot right there. So that would be a negative 10 comma 3. That would be my vertex from a standard form. So now if you're looking at a vertex from a vertex form, it's a lot different than a standard form. Because this is a vertex form, it already gave you a vertex. Remember that this is h comma k. So my vertex is actually given. Remember that the inside is opposite, so when I have a negative 1, the real x value for the vertex is 1, comma, the outside stays the same, so 1 comma negative 1. Just like last time, my vertex, the x value, is my axis of symmetry. So if I already have a vertex, my axis of symmetry would be the x value of my vertex, x equals 1. So those are my vertex and axis of symmetry. A lot more simpler because I gave it to you in vertex form. Last but not least, you got your x-intercept form. So you got y equals to 2 times x plus 10 times x plus 4. Now remember, this is the form you have to remember. This is y equals to a times x minus p times x minus q, where p and q are your x-intercept. So your zeros or your x-intercepts are p equals and q equals. Remember that. Okay, so in this case, my zeros is p equals to negative 10 because the sign is opposite, and q equals to negative 4 because it's opposite of what's inside. Now, I know my zeros. And that means that I need to work to find my axis of symmetry. So I'm going to do a quick sketch. Just a sketch. Here we go. I know that my zeros are at negative 10 and negative 4. Those are my two zeros. Remember, axis of symmetry is the middle of the graph. So if these are my two zeros, what's in the middle of all of this? To find the middle, let's figure out. How much is it from negative 4 to negative 10? That is a negative 6 unit. Negative 6. So what's the halfway point from a total of negative 6 distance? Well, you have 3. You go this way to the left, 3 units. So negative 4, negative 5, negative 6, negative 7. This point right there, your axis of symmetry, is at x equals to negative 7. So here it is. My axis of symmetry is in the middle of my two zeros. X equals to negative 7. And then to find the vertex, you have to take the axis of symmetry, negative 7, and put it in as your x value. And figure out what the y value is by plugging it into the equation. So y is equal to 2 times negative 7 plus 10 times negative 7 plus 4. Working it out, y equals to 2 times negative 3 times negative 3. Sorry, 2 times positive 3 times negative 3. That's going to give me y equals to 2 times negative 9. So y is equals to negative 18. That number goes in the y value of my vertex. So my vertex is at negative 7, comma, negative 18. There you have your axis of symmetry and you have your vertex. Okay, and then the next part I want to look at is I want to actually take a look at how do you write an equation by looking at a graph. If you're looking at I'm going to look at number 13 on your review. On number 13 of your review, they want you to write an equation of this graph right here. I'm looking at this graph. I noticed that it went through 6 and 4 as your x-intercept. Those are your zeros. Because I have x-intercept, I also have a point. I can pick this point right there. That is my point. I have x-intercept and a point. I'm going to use my x-intercept form. Remember, this is a form that you have to remember. Y equals to a times x minus p times x minus q. That's the x-intercept form. I already know p and q. Those are my zeros. Those are my x-intercepts. I need an x and y. X comma y is a point. I already picked that point. That point is 3 comma 3. So my x is 3. My y is also 3. Okay, so let's list out all my points I have. P equals to 4. I have q equals to 6. I also have x equals to 3 from this point right there. And then I have y is also equals to 3 from this point right there. So y is also equals to 3. Now I can take PQ, XY and plug it into that formula. So y right there, y is equals to 3. So I would write 3 equals to. I don't know what a is because there's no a in here. So I'm going to write a times, I do know x. There is an x right here. So anytime I see x, it's equals to 3. So it'll be 3 minus, my p is one of my 0, which is 4. So 3 minus 4 times x again is 3 minus, my q is in the other 0, which is my 6. 3 minus 6. And then now working it out, 3 equals to a times negative 1 times negative 3. These works out to be positive 3, so 3 equals to a times positive 3. Solving for a, divided by 3 on both sides. That goes away. A equals to 1. So using this piece of information, I can now plug in A equals to 1 into my formula. Final equation, y is equals to, A is 1, times x minus, p is still 4, times x minus q is still 6. And that is my final equation. All right, I got 2 more that I want to take a look at. On the back of this page, remember what we said, there was some solving absolute value equation review, and there's a system review. So let's take a look at number 15, solving absolute value equation, and then take a look at number 20, solving a system. And then that would be it for our no calculator review. All right, so let's take a look at number 15. Number 15 says, hey, I gotta solve this. Remember, we use I, R, S. I represents isolate your absolute value. R represents rewrite into 2 equation, and S represents solve. So here we go. Isolate the absolute value. This is my absolute value right here. So I need to get this one by itself. That means I take everything away. The first thing I undo is an addition. To undo plus 8, I have to subtract 8 on both sides. So that's going to give me 7 times absolute value, negative 9x minus 1, equals to, let's see, 10 minus 8 is 2. That would be 56. And then to get absolute value by itself, I need to get rid of the 7. I divide it by 7 on both sides. That's going to give me absolute value of negative 9x minus 1 equals to 8. Okay, absolute value is isolated. I is done. I'm going to rewrite it into 2 equations. That's when I take it out of the absolute value. So I have negative 9x minus 1 is equals to positive 8. Out of the absolute value, negative 9x minus 1, this time is equals to negative 8. So I rewrote it. Done. The third thing I need to do is to solve. Plus 1 on both sides. Negative 9x equals to 9. Divide by negative 9 on both sides. That gives me x equals to negative 1 as one of my answer. Keep going on the other answer. Add 1 on both sides. Gives me negative 9x equals to negative 7. Divide by negative 9 on both sides. That gives me x equals to positive 7 over 9. And that would be my other solution. So I just solved it. Okay, so that is solving absolute value equation. Last but not least, number 20, systems of 2 equations. You can solve it any way you want. What I see same number, but same sign. So what I'm going to do is I'm going to take one of these equations and multiply it by negative 1 so I can get same number, opposite sign. Let's rewrite this. The first equation I didn't change, so negative 8x minus 4y equals to negative 28. Second equation, I multiply negative 1 into the entire equation. So that's going to give me positive 8x, negative 8y equals to negative 8. And I'm going to add the 2 together. Combine my term. Negative and positive goes away. Negative 4 and negative 8, negative 12, y equals to negative 28 and negative 8. It's going to give me negative 36. Now that I got rid of one variable, I can solve for y. Divide by negative 12 on both sides. I get y is equals to positive 3. Now I have a y equals positive 3, plug it back into the original, one of the original equation. It seems easier to do it with the 8s. So plug it in, negative 8, don't know what x is, plus 8 times, I do know y is 3, equals to 8. So working it out, negative 8, multiply 24, equals to 8. Subtract 24 on both sides. Negative 8x, that goes away, equals to negative 16. Divided by negative 8 on both sides. X equals to positive 2. Now you have x and y. You can write it as an order pair, like 2, 3, or you can just write it as x equals to 2 and y equals to 3. Either one of these will give you full credit. And that is a quick review of everything that we have done in Unit 3.